This is the video for the practice for SLO 3 and 4. I am using the example 3 from the notes 1.4 to get a head start on this, because a lot of what had to be done in that example is exactly what you're going to have to do on your SLO. So you're going to be given a polynomial, and part A, you're going to be asked to find all the possible rational roots using the rational root theorem. Part B, use synthetic division to find the first zero. In that video for that example, we used the graph in Desmos or whatever graphing calculator you're using to give us a hint to find a good choice to try for the first zero. Part C, use synthetic division to find a second zero, again using the graph to get a hint. And then part D is to find the remaining zeros either using factoring, square root property, or the quadratic formula. So all of that was done in the video for example 3 from 1.4. Remember to use your result from the first synthetic division as your starting point for the second synthetic division, and use your result from the second synthetic division as your starting point to find the remaining zeros for factoring or quadratic formula or the square root property. So the remaining part that you need to know to successfully complete the SLO is not hard, and it's not new. It's review from 1.2 actually. The part E is to find the y-intercept algebraically. We find y-intercepts by substituting 0 in for x. So our function h of x is x to the fourth minus 5x cubed, and so on. Everywhere I have a 0, everywhere I have an x, I'm going to replace it with 0. And that simplifies to be 10. So my y-intercept, which is a point on the graph, should have xy coordinate is 0 for the x and 10 for the y. The last part of the SLO is part F. It has 4 parts, and I've listed them one on each line here, but that's not the way it's written at the SLO, so just make sure you do all 4 parts. We're supposed to graph the polynomial. You absolutely can do that by hand on your blank paper or lined paper, but you can go to Google, search up graph grid, whichever one works for you. You can print it out or import it into your digital document. But if you do the graph by hand, that's okay, as long as you try to be kind of consistent with your scale. So from part B, we know there is a 0, which is another word for x-intercept at 2, 0. From part C, we know there is a 0 or an x-intercept at -1. From part D, we know there's another 0 or x-intercept at 5, and then we also got -1 a second time in part D, so we know that root has multiplicity 2. From part E, I know my y-intercept is 10. I'm not going to try to put those 10 little tick marks on the y-axis. I don't have to, you don't have to, just label the point that you have. So make sure you use your results from part A through E on your graph. And to help us finish that graph and to satisfy the fourth thing that they're asking, we're going to get a table of values. And you can make this yourself, but Desmos will help you. So kind of close to my term 3x squared that you can see typed into Desmos. Above it, there's an icon that kind of looks like a gear. If you tap that, you get some new choices. And after what you can see of x to the fourth minus something for this function, we now see an icon that looks like a table. If you click on that, Desmos will create a table for you. And if you don't like the x values or you want to add x values, you certainly can, but that will get you a head start. So for your SLO, I'm going to make a table, and I'm going to start with the points I already have from my previous work. So when x is -1, we know the function is 0. When x is 0, the function is 10. I'm going to leave a little space because the next one I know is when x is 2, the function is 0, and I'm going to leave another little space because the next thing I know from my previous work, so when x equals 5, y is 0. And I'm going to fill in gaps with what I get from Desmos or work by hand. So when x is -2, the function is 28. There's a gap between 0 and 2. So when x is 1, the function is 16. There's a gap between 2 and 5. I can use 3 or 4 or both. I'm going to recommend you do at least one x value in any gaps you have, and to the left and to the right, but more is definitely okay. And to the right of 5 would be 6, and the function is going way up to 196 there. So using this information, when x is -2, the function's way up here. That's not high enough for 28, but that's all the room I have. And when x is +1 by 16, that's probably kind of close to correct. When x is -3, the function's way down here. That's probably not far enough, but again, I don't want to take up too much room. And then when x is 6, the function's way, way, way up there. So based on what I have on my table, my work from before, and what I see in Desmos, my graph looks something like this. It's not perfect. I don't expect yours to be perfect, but you do need to make sure you go through the points you found in parts A through E. Try to have the major important behavior, put arrows on both ends. And that finishes our graph and our table. So to finish this part F, I need to state the end behavior. And the terminology used in the online homework assignments is either rises to the left or falls to the left, and rises to the right or falls to the right. So on this graph, to the left would be as x goes to -infinity, -1, -2, -10, -100, and as that happens, this graph is going to positive infinity. So this graph rises to the left. And doing that same thing, but on the right-hand side, as x gets bigger and bigger, 5, 10, 100, 1000, the y is also going up. We saw it was already 196 when x was 6, so this also rises to the right. Your problem for the SLO might be looking very different, might be falling to the left and to the right, or rising on one side, falling on the other side. But whatever you see in the graph, make sure you explain that in your end behavior part of F. And so that finishes the end behavior. And then the last part I need to do to finish this SLO is the 0 behavior. I need to state the behavior and the multiplicity. So there's 3 multiplicities that are possible. The first one is when the multiplicity is 1, the graph crosses the x-axis, and we see that behavior here when x is 2 and 5. So the graph crosses the x-axis at 2, 0 and 5, 0, because the multiplicity is 1. The second multiplicity behavior we see in this graph is at the last x-intercept -1 in our graph. The graph didn't cross the x-axis, it touched the x-axis and turned. That's happening at -1, 0 in this problem because the multiplicity is 2. And that finishes the description of the behavior at the zeros. So that finishes my SLO. In general, the third 0 behavior is if you have multiplicity 3. The graph crosses the x-axis, but it flattens out like y equals x cubed flattens out near the origin. But make sure you list the behavior you see in your problem for your SLO. If you have any questions, please send me an email.